craftsmen. Russia rolled into Ukraine in 2022 with one of the biggest, strongest tank fleets ever assembled.
It was expected that modern marvels like the T-90M would secure a crushing victory for Putin. Instead, the Russian army has suffered historic, unprecedented tank losses due to incompetent tactics and embarrassing intelligence failures. Russia has been famous for tanks since World War II, deploying mighty machines like the iconic T-34. Reports indicated Russia had close to 3,000 operational main battle tanks at the beginning of the war.
These active MBTs included modern T-80 and T-90 models, regarded as highly effective and powerful machines.
The early days involved Russian forces assaulting Ukraine along 5 major axes, striking big city centers like Kyiv.
By the end of spring, progress stalled, and supposedly unbeatable tanks were blown to bits by brave defenders.
Analysis cites the rapid rise of unmanned aerial systems, which changed the state of play completely for armor.
Visual evidence verifies over 4,000 Russian tank losses since the invasion began, along with thousands of vehicles.
These losses account for the largest armored vehicle destruction Russia has suffered since the end of World War.
Forces are dragging rusty old relics out of storage facilities to replace modern tanks destroyed in recent battles.
Decimated by a chaotic cocktail of factors, Russian troops now run into battle with minimal armor backing them.
The United States sent thousands of Javelin anti-tank missiles.
The T-72 features a design flaw, where ammunition stored in the turret makes it a death trap.
The T-14 Armata is too expensive to make, and Russia fears losing them to cheap drones. Russia is reduced to near-suicidal assaults using lone vehicles equipped with crude ad hoc metal cope cages.
Putin and his commanders continue to burn through resources and throw men into the massive meat grinder.
The Russian army remains unable to make the most of its armor advantage despite historic military-industrial strength.
Soviet forces once produced machines like the Su-152, with enough firepower to destroy any vehicle. The T-72 became the backbone of Soviet forces, until the Union eventually dissolved and ceased to exist.
Military analysts pointed to Russia's enormous stockpiles of tanks as the Kremlin's single biggest advantage during invasion. Thousands of tanks were stored in warehouses, ready to roll out onto the battlefield should they be needed.
Analysts expected these tanks to spearhead assaults on major cities like Kharkiv and the strategic capital of Kyiv.
Putin and his commanders were confident of quick victory, foresure in no way Ukraine could stop these machines.
Russian progress hadn't just slowed, it had stalled, and captured land was reclaimed by brave Ukrainian forces.
Russia continues to rely on small infantry forces without armor, backing them up in a big ground.
Strategic shifts were published on official army websites, citing devastating losses over the course of the conflict.
We don't know exactly how many tanks were destroyed, but the figure is clearly in the thousands today.
Verified losses in Ukraine mean Russia has lost up to 143% of original force.
Russia is running on empty, dragging relics, 50, 60, or even 70 years old, out of storage.
Overconfidence and arrogant tactics at the start of the war are partly to blame for subsequent losses.
Leadership felt absolutely sure it would be over in days, failing to plan with precision and intelligence.
Tanks were often dispatched in random, illogical ways, with minimal tactical oversight, resulting in cornered and destroyed units.
Ukrainian forces utilized their own mines, missiles, and artillery, making the most of their home field advantage.
Russia is frightened about using tanks because they face an enemy that has mastered blowing them apart.
Subscribe to our channel today and turn on notifications to see our latest reports from the front.
Manufacturing precision components for Russian tanks requires rigorous quality control and advanced robotics on the line today.
Explosive reactive armor is designed to neutralize incoming projectiles, but remains vulnerable to modern top-attack missiles. Managing the intense heat of high-horsepower tank engines is critical during sustained high-speed offensive maneuvers.
Titanium additive manufacturing reduces the weight of internal parts while maintaining the strength needed for combat operations. Calibrating laser rangefinders ensures that the tank's main gun can strike targets with pinpoint accuracy in battle.
Road wheels are machined with precision to ensure the tank remains mobile across challenging and muddy terrains.
Testing automated loading systems ensures they operate flawlessly under the intense pressure of a high-stakes tank engagement.
Managing the complex electrical network of a main battle tank is vital for powering advanced targeting sensors.
Ensuring high-quality fuel prevents engine failure during rapid advances across contested and dangerous military front lines.
Internal communication networks are the nervous system of the tank, providing data to the commander in real time. High-pressure water jet cutting preserves the integrity of specialized steel armor plates used in The final integration of the turret is a monumental task, requiring precise coordination of heavy industrial machinery.
Cold start testing ensures that armored forces can operate reliably in the freezing winter conditions of Ukraine.
Automated vehicles move heavy components efficiently through the plant, reducing the risk to the logistics personnel today. Regular software updates ensure that modern fire control systems can accurately track moving targets in complex environments. Robotic painting systems apply specialized coatings with perfect thickness to reduce the vehicle's visibility to enemy sensors. Machining drive sprockets from high-strength alloys is essential for the durability of the tank's heavy propulsion.
Monitoring signal waveforms ensures that the tank's electronics remain stable during the high intensity of modern battle.
Industrial production of internal cooling systems supports the massive engines of the armored vehicles on the front.
Regular hull inspections are necessary to ensure that main battle tanks remain safe during long combat missions.
Laser scanning ensures that every component meets the strict tolerances required for high speed and intense maneuvers.
Rolling metal into thin sheets provides the lightweight material needed for internal panels and non-structural parts.
Designing durable transmission systems is critical for moving 40-ton armored machines through thick and heavy mud. Testing auxiliary power units ensures that the tank's electronics can operate even when the main engine is. Non-slip coatings are applied to ensure that crew members can safely move across the vehicle surface. Targeting optics must be perfectly calibrated to ensure that the commander can see through smoke and dust. Curing composite materials in industrial ovens provides the lightweight strength needed for modern multi-layered tank armor. The automated vehicles move heavy munitions efficiently through warehouses, reducing the risk to the logistics personnel in plant. Managing the vast supply chain for tank parts involves thousands of components delivered daily to assembly plants.
Drilling precision holes in the mounts ensures that external fuel barrels remain secure during intense cross-country.
Managing the complex electrical grid of a jet requires constant monitoring to prevent any critical systems failure. Semiconductor production is a national security priority for maintaining the technological edge in modern armored warfare today.
The future of national security depends on the industrial strength and the armored capability of the fleet.
Night operations testing ensures that the tank can achieve dominance in any lighting or difficult weather conditions.
Regular software updates ensure that the vehicle remains capable of countering the latest anti-tank missile threats.
Storing sensitive electronics in a controlled environment prevents damage from heat or moisture before their final installation. Moving the massive chassis through the factory requires coordination and precision to avoid any structural airframe damage. Manufacturing precision components for the tank requires rigorous quality control and advanced robotics on the production line. Automated vehicles increase the speed of the production line by moving heavy parts throughout the factory safely.
Every switch and button is designed for intuitive use by crew during the intense pressure of combat.
Drilling precision holes in the turret ensures that smoke launchers are held securely during the high speed.
Storing sensitive electronics in a controlled environment prevents damage from heat or moisture before their final installation.
Grinding gun barrels to precise dimensions ensures that projectiles follow a flat and accurate trajectory in battle. Steel purity is essential for ensuring that armor plating can withstand the impact of high-velocity projectiles.
Installing the engine is a critical step in the industrial production of a modern main battle tank.
Efficient logistics ensure that armored divisions remain fully supplied with ammunition during a high-intensity military conflict.
Virtual reality design allows engineers to detect structural problems before a single piece of steel is cut. Testing laser warning receivers ensures that the tank crew is alerted when they are targeted by missiles.
High-quality track assembly is vital for maintaining the mobility of armored forces in the most difficult terrain.
Cooling systems are essential for preventing engine overheating while simulating the brutal conditions of sustained combat operations. Heat-resistant coatings protect critical components from the extreme temperatures generated during the firing of defensive munitions.
Clean room assembly ensures the reliability of the electronic systems that provide reconnaissance for the armored columns. Drive sprockets are machined with precision to ensure perfect engagement with the tank's heavy steel track links.
Verification of smooth turret rotation is necessary for the tank's ability to quickly engage targets in battle. Hardened tactical servers process vast amounts of battlefield data to provide the crew with situational awareness today.
The scale of modern defense production involves thousands of workers and billions of dollars in specialized technology. Simulation training prepares tank crews for the complex challenges of modern armored warfare in a safe environment.